Okay, this is the second recording, this lesson. Difference of two squares, that would be x squared minus 1 on x squared to the power of 40. Now, for the term independent in x, we can do it the long way, or can anyone take a guess what they think? You know how we've got the general term is nck. You know how these are both the same, x squared, one at the numerator, one on the denominator. To get a term independent in x, we would need to cancel the x's, would we not? Do you think it's going to be a quarter of the way along the expansion or middle of the expansion where your powers of x would end up being the same? Anyone have a guess what they think? What's the 20? But it's okay. It's going to be where k is 20, but what's the formula for the general term? 40 ck a to the n minus k, the second term to the k. That's my general term, isn't it? Now, what do I have to do with that? I've got to do with it what I did before. I've got to break everything up. So it's 40 ck x. It's a minus there. Yeah, that is a minus there. Yep, x to the negative 2. Yeah. So we've got x to the what here? 80 minus k. I've got negative, I know I did this again. Who would be getting this question wrong on the exam? It would be me. So 80 minus 2k. Haven't we got negative 1 to the k? And isn't this x to the minus 2 to the k? So I want the negative, has to be to the power of k, and that is x to the minus 2, it's also to the power of k. So I've got, let's put all my coefficients up the front. I've got 40 ck, negative 1 to the k, x to the 80 minus 2k times x to the minus 2k, which gives me, I know I've taken a lot of lines, x to the what? 80 minus 4k. Okay, now, are we okay with this, girls? Please, this negative 1 on x squared, the negative 1 is the coefficient. It's got to be, you've got to make it to the power of k as well. And 1 on x squared is the same as x to the power of negative 2. That's to the power of k. The idea is that you've got two things here, x to the power of k, two types. So you have to be able to combine those. Bases are the same, add the indices. Now for the term independent in x, for the term independent of x, in other words, the constant term, girls, constant term's not always on the end, not when you've got an x squared minus 1 on x squared, it's when the x squareds cancel out with these x squareds. That's the term independent in x. It'll be halfway through the expansion. Alright, now, no, we'd never be asked to expand something this big. So for term independent in x, 80 minus 4k will equal 0. It'd be the x to the 0 term, wouldn't it? The term independent of x is when you've got x to the power of 0. What's x to the 0? 1. So when the x is gone, you've got the term independent of x. So for term independent of x, 80 minus 4k equals 0. So in other words, k is 20. So therefore, the term independent of x is 40c 20, negative 1 to the power of 20 x to the 0, which is just 40c 20. What's negative 1 to the 20? Even power of negatives. Anyone? That's it. Times 1. That's it. It's just 40c0. Times 1, which is 40c20, sorry. Yeah. Because negative 1 to the 20 is 1. X to the 0 is 1. So the term independent of x is 40c20. And then if you want, of course, I would never make you wind that down 20 times. All right? So, and then you can write down what the term is. And the term is, using your calculator, what do you get? 0.378 times 10 to the power of 11. Approximation, as the values of n and r are very high. If you were asked to give that as a number, it would go, that is approximately equal to, in scientific notation. Do another one. Coefficients of the terms specified in this expansion, 3 plus x times 1 minus x to the power of 15, that times that. I want the term in x to the 4. If you want the term in x to the 4, girls, there are two ways to get it. I suggest we listen very carefully. That's a 13, that's a 15. How do you think, see girls, see this 3 plus x, it's going to be multiplied by different terms in that. So I want two things. The 3 times which term in here will give me 3 times x to the 4 term will give me an x to the 4 term, and x times the x cubed term here will give me an x to the 4 term. Do you see that, girls? I mean, I can go out and write the expansion of that and take forever, right? But, you know, once I expand this, how am I going to get an x to the 4 term? You know, this 3 and x have to be multiplied by that expansion. 3 times an x to the 4 term will give me an x to the 4 term, and x times the x cubed term in this expansion will give it to me. So, I'm just going to deal with the second one, and I'm going to find the terms in x cubed and x to the 4. So to do part 1, to find the terms in x to the 4, first find the terms in x cubed and x to the 4 of the expansion 1 minus x to the 15. Now, girls, we don't need general term business. This is just an easy expansion. Well, or you can go general term, it's fine, if you're a bit worried. So, general term in 1 minus x to the 15 is... Actually, what don't we can work out the x cubed instead of the general term. Why don't we write out our terms in x3 and x4? Term in x3. Sorry. What's the term in x3? Because it's just a 1 minus x to the 15. What would it be? All right, I'll write you the general term. A plus x to the n is nck. A to the n minus k, x to the k. Wouldn't it be... Oh, got a bit of a problem. Because it's a negative. Oh, no, it'll be okay. Yeah. All right, what would it be? All right, term in x cubed of... Do you want to just do the general one? I don't know if I do the general. Wouldn't it just be 15c12? 3. Yep, 1 to the 12, negative x to the 3. Wouldn't that be it, the term in x cubed? Yeah, 15c3, 1 to the n minus k, x. But remember, I can pull that negative out. All right, so that's just a coefficient. It's still the... I'll show you what I mean. 15c3, 1 to the 12 is 1. Don't I do times negative 1 cubed times x cubed? So the coefficient of the x cubed term is just negative 15c3. Well, that's the term in x cubed. No, I've decided not to do the general form. I don't think there's any need for it. I don't think there's a need for it because it's just the 1. You know when you've got the expansions of 1 plus x or 1 minus x, they're very simple. I've got no x term here. Like if you look at this basic format, nck, this k down here is the same power as that x. Do you want the general term? You can. You can do the general term if you want. I don't... All right, I'll just show you. If I've got the x cubed term here, right, let's just leave that at the moment. What's my term in x to the 4 going to be? Isn't it just going to be 15c4, 1 to the 11, negative x to the 4, which is 15c4, negative x to the 4. It's negative 1 to the 4. What's that? Isn't that just 1? So I'll show you now. I'll show you now. I'll show you now. So that's my term in x to the 4. 15c4 x to the 4. Now, when I look at my original thing, 3 plus x times 1 minus x to the 15, when I expand 1 minus x to the power of 15, two of the terms are going to be whatever. I've got my x cubed term is minus 15c3x cubed plus, so I've just got a couple of terms. I'm not writing out the whole expansion, girls. I don't need to. But I'll tell you, the term in x cubed is that. I'm missing the first few terms. That's my term in x cubed. This is my term in x to the 4 plus, I don't care what the others are. So if I were to write the full expansion of that, which I'm not going to, that is the term in x cubed, that's the term in x4. Can you now tell me what you think the term in x5 would be, by the way, looking at this pattern? 15c5x5. What would be the term in x squared? 15c2x squared. So if that was fully written as an expansion, there are two ways I can get terms in x to the 4. I could multiply this 3. Once this is expanded, don't I need to multiply the 3 plus x by all of that expansion? So 3 times the x4 term will give me an x4 term, and x times the x cubed term will give me an x4 term. Do you get that? So therefore, the term in x4 for the whole thing in 3 plus x times 1 minus x to the 15 is two ways. 3 times 15c4x4 plus x times negative 15c3x3. There are two ways to get it. We'll do another one of these. How? Look, it would be 3. The constant times the x4 term will give me an x4. And the x times the x cubed term gives me an x to the power of 4. There are two terms that will give it to me. So it's the 3 times that and the x times this one. So what have I got? What's 3 times 15c4? You can work it out on your calculator. 15c4, anyone? Oh. All right. You're confused? Do you understand? Well, if I had a full expansion of this, wouldn't you do 3 times everything in that? And x... Yeah, but which one? It doesn't matter. If I do 3 times that, it doesn't give me a term in x4. So I'm not worried about that one. I only am picking out the terms. Girls, I'm not going to write out 30 terms, actually 32 terms to expand the whole thing. Just by using common sense, if you do the only way I'm going to get an x to the 4 term is if I multiply the 3 by the x to the 4. If I multiply by 3 by x cubed, do I get an x to the 4 term? No, I'm not interested in that one. To get an x to the 4 term, that x4 has to be multiplied by a constant. It's still x to the 4. And to get another x4 term, the x has to be multiplied by the x cubed. I'm not worried about the other 30 terms, and there will be 30 other terms. I only want the term in x to the 4 in that product. Because it'll be that plus the other one. They're both going to be x to the 4. So I've got this times that one plus this times that. Because when you do an expansion, don't you go that times that plus that times that plus that times that when you expand? Girls? Do you want me to do a big expansion down here? All right, so what's 3 times 15c4? You know, you can do it with factorials if you want. Haven't we got 3 lots of 15 factorial over 11 factorial times 4 factorial, x to the 4, minus 15 factorial over 3 factorial 12 factorial x to the 4. That's what you've got. Look, 3 times 15c4 plus, there's a negative here, in other words, minus 15c3 x to the 4. If you want, you could do it like that. X to the 4 is a common thing. You could go common denominators if you want. Do you remember how we did that another lesson? Do you remember how we did it? I don't care, just do it on your calculator. Now what you'll do, girls, you've got 3 times 15c4 minus 15c3.
Which equals this?
Yep.
3,640.
3,640
Yes.
is x to the 4. So that's the coefficient. So you work out each one and you subtract. Because there are 2 ways of getting x to the 4. Look, watch what I'm doing. Let's say I've got the expansion. I'm going to write out the expansion. 15c0 x to the 0 minus 15, girls, what do you mean? What do you mean? Oh, sorry. Yeah, okay. So, you understand the idea of the expansion? Girls, do you get the idea of the expansion? I'm starting to write that expansion out fully. I would only get an x to the 4 term by multiplying that with that and that with that one. There's no point doing the x5, x6, x7, x8, x9, 10. They're not going to give me a term in x to the 4. 3 times the x to the 4 term and the x times the x to the 3 term. All right.